All right, guys, it's Chavez here. I'm doing a quick overview. I'm doing this during advisory, so if you hear some of my kids in the background, that's fine. So here we go. Call this an overview. So the first question it says, which of the following could be a slope field for the differential equation dy dx equals x squared plus y? So the first thing to notice, guys, is that 3, 2. Hey guys, Chavez here. I'm doing a quick overview of this exam. If you hear my kids in the background, it's because we're in advisory and they're working on their little projects and stuff like that and their work. So here we go, overview. Question 1, which of the following could be a slope field for the differential equation dy dx equals x squared plus y? So the first thing I would do, guys, I would go down the x and y axis. So let's go down the y axis. Or I guess let's go down the x axis first, since the x is being squared here. So if the y is 0, and notice that it's x squared, so I should never have negative slopes on x squared. So notice on this one I have negative slopes and positive slopes, so A's out, and then positive slopes, and then negative slopes, so B's out. Let's see, so now, actually from that alone, we can probably already figure it out. I see negative slopes here, positive slopes there, so that one's out. Positive slopes, okay. Now, if I go down the y-axis, so that means the x value is 0. So I should have positive slopes if I have positive y values, I do. And negative slopes if I go down, and I do. So there it is. So the answer is D. That one was worth 1 point, guys. All right, this question here, let y equals f of x be a particular solution to the differential equation with initial condition f of 0 equals negative 2. Which of the following is an expression for f of x? So what you do, guys, is separate the variables. So y dy equals x plus 1 dx. Put that in parentheses. You don't have to. You can just, take antiderivative. And then you're going to go y squared over 2 equals x squared over 2 plus x plus c. This is a good place to maybe do this. 0 comma negative 2. So I'm going to plug in 0 for x and negative 2 for y. So negative 2 squared is 4. 4 divided by 2 is 2. So 2 equals 0 plus c. So c equals 2. And I'm going to plug that in right there. So I'm going to write y squared equals y squared over 2 equals x squared over 2 plus x plus 2. I'm going to go ahead and multiply by 2 to get rid of the 2 in the denominator here. So I'm going to go times 2 and then times 2. When you do that, you're going to get y squared equals x squared plus 2x plus 4. And I'm going to go square root. So y equals plus minus square root of x squared plus 2x plus 4. So that's the biggest mistake. You guys didn't put plus minus. When you plug in a 0, you better get negative 2. So 0, 0, square root of 4 is 2, but I want it to be negative, so it's a negative 1. So there it is. That was worth 2 points. This one here, I feel like some of you just didn't know how to find average value of a function. Let f be the function defined by 1 over x. What is the average value of f on the interval 4 to 6? So average of f, hold on. Sorry for a quick pause there, guys. Someone asked me a question real quick, so I had to pause it. All right, so average of f is equal to 1 over b minus a, integral from a to b of f of x dx. Don't be a robot. Remember how we derived that? We derived it from the average velocity. Average velocity is equal to displacement divided by time, and displacement is equal to integral from a to b of v of t, and then b minus a. It looks cleaner when you go like this. So, but there it is. That's how we derived it. We derived it from that. All right, so here we go. I want the average value. 1 over 6 minus 4, integral from 4 to 6, 1 over x dx. So 1 over 6 minus 4, that's 1/2. Antiderivative of 1 over x is ln of x. And I am evaluating this from 4 to 6. So 1/2 ln of 6 minus, that's a 6, minus ln of 4. And 6 over 4, so now we're just using the quotient properties of logs. So ln 6 over 4. 6 over 4 is the same thing as 3 over 2, guys. So 1/2 ln 3 over 2. And there it is. So I think both of those together was worth 4 points. All right, this one here, a student attempted to solve the differential equation dy dx equals xy when initial condition y equals 2 when x equals 0. In which step, if any, does the error first appear? All right, so they separated the variables correctly here, so that's correct because, dy over y equals x dx. And then they took the antiderivative, and the antiderivative of dy over y is ln absolute value of y, x squared over 2 plus c. That's fine too. And then they did E and E, and so E and E. So I should have absolute value of y equals e to the x squared over 2 plus c. And there it is. Wrong. That plus c should be part of the exponent there. So there it is, guys. Step 3. And I think that was worth 2, all or nothing, I believe. All right, let's go ahead and go to this one. Consider the differential equation dy dx equals 1/3 x, y minus 2 squared. A solution for the given differential equation is shown below. Sketch a solution curve that passes to the point 0, 2, and the solution curve that passes to the point 1, 0. So the 0, 2 is pretty straightforward. That's just a linear line. See? And then this one, just follow the... It's supposed to be kind of symmetric. And I guess right here it kind of starts falling apart for me. Let's see. Boom, boom, like that, something like that, and it looks symmetric about the y-axis there. All right, let's go to letter B. Let y equals f of x be the particular solution to the given differential equation when initial condition f of 1 equals 0. Write an equation for the line tangent to the graph y equals f of x at x equals 1. Use your equation to approximate f of 0.7. All right, so what they want you to do, guys, is find a tangent line. So tangent line, you need a point and a slope. I already got the point right here, 1, 0. So now I need my slope. So I'm going to go dy dx evaluated at 1, 0 equals 1/3 times 1, parenthesis 0 minus 2 squared. So this negative 2 squared is 4 over 3. So there's your dy dx. All right, guys. And then you're going to go y minus 0 equals 4/3 x minus 1. And this is a tangent line that I want to use to approximate f of 0.7. So I'm going to go f of 0.7 is approximately 4/3 parenthesis 0.7 minus 1. And then plus 0, but there's no reason to do that, right? So negative 0.7 minus 1 is a negative number. So you can go 4/3 times the negative 0.3, which is the same thing as 3/10. These 3's cancel out, and you get 4 over 10, which is the same thing as 2/5, negative 2/5. Or you can say negative 0.4. They're both the same. Oops. They're both the same, guys. So whichever one you guys think is easier. All right, let's go to the next one. Oh, that's it, right? Use your equation to approximate. That's my approximate right there, negative 0.4. All right, guys, let's do this one right here. It says, find the particular solution y equals f of x is given differential equation with initial condition f of 1 equals 0. So start with your differential equation. Start with this guy right here. So write dy dx equals 1/3 x, parenthesis y minus 2, close it squared. Was it y minus 2? Yeah. So the y's with the y's, the x's with the x's. So dy over y minus 2 squared equals 1/3 x dx times dx, divide, right, by y minus 2 to get it down there, excuse me. Then you're going to antiderivative or integrate. Now you have a 2 right here, guys. So some of you guys were telling me that this was ln, but it's not because this is a quadratic. So this is like saying, side note, this is like saying integral 1 over x squared dx. So remember, that's the same thing as saying x to the negative 2 dx, like that. So antiderivative, add 1, divide by that number. So x to negative 1 divided by negative 1, so negative 1 over x plus c. So this is just a side note. So that's the same deal with this. So negative 1 over y minus 2 equals, and I guess you could put plus c there, but don't. Put it on the right-hand side here. 1/3 x squared divided by 2. So when you divide by 2, just multiply that 3 there. So 1/6 x squared. You can also say x squared over 6, which I think that's what I'm going to do. X squared over 6 plus c. And here's a good time to just plug in 1, 0. So I'm going to insert 1, 0 in here. So 1's the x, 0 is the y. So 1 over 0. Hold on. 1 over 0 minus 2, so negative divided by negative is a positive, so 1/2 equals 1 squared is 1, so 1/6 plus c. So from there, c equals 1/2 minus 1/6. I'm doing the overview for differential equations, Mata. Oh, okay. And c equals times 3, so I'm going to say 3/6 minus 1/6, so that's 2/6. So let's write that as 1/3. All right, so I think we got that. We're going to plug it back in right here. So negative 1 over y minus 2 equals, you know what? I'm going to use a 2/6 because I see the x squared over 6, and I want to have a common denominator. So plus 2/6. So negative 1 over y minus 2 equals x squared plus 2 over 6. Move the negative to the other side, or times negative 1 times negative 1. 1 y minus 2 equals negative. And then if you want to write it x squared plus 2 like this, I guess you don't have to put parentheses. You can just make sure that the negative is far enough away. Flip. So y minus 2 equals negative, and then 6 over x squared plus 2. I just flipped my ratio here, or my fraction here, and then just move the 2. So let me write it right here. Y equals negative parentheses 6 over x squared plus 2, close it, plus 2. All right, I don't see any issues. I hope that takes care of everything. When I plug in a 1, I better get a 0. 1 squared is 1. 1 plus 2 is 3. 6 divided by 3 is 2. I have a negative in the front. Negative 2 plus 2 is 0. It works. So there it is, guys. All right, last one here. I have this expression here. Hold on, I'm going to pause it really quick. I have to pause really quick. Here we go. Consider the differential equation dy dx equals y squared over x minus 1. On the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So we're just creating little slope fields. That's it. So at the last points, you're just going to create your little slope. So this point here is 0, 0. If I plug in 0, 0, you get 0 divided. That point here is 0, 0. If I plug in 0, 0, you get 0 divided by negative 1, which is 0. So bam. If I plug in 2, 0, you get 0 divided by 2 minus 1, which is 0 divided, so that's 0 again. So there it is. Plugging in 0, 1. So if I plug in 0, 1, 1 squared is 1 divided by 0 minus 1, that's negative 1. So I'm going to get a slope of negative 1. If I plug in 0, 2, 2 squared is 4. 0 minus 1 is negative 1. So 4 divided by negative 1 is negative 4. So just make it steeper. Steeper in the negative direction. And then 2, 1, same thing, guys. Plug in a 1 there. 1 squared, 2 minus 1 is 1. So 1 divided by 1 is 1. So slope of 1. And then at 2, 2, 2 squared is 4. 2 minus 1 is 1. So slope of 4. Just make it steep. And there it is. Hopefully that made sense. Letter B. It says let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. So here's my point. So the point is 2, 3. Write an equation for the line tangent to the graph at x equals 2. Use the equation to approximate f of 2.1. Okay, so I want a tangent line, see? So I want a tangent line, so I need a point and a slope. So dy dx at the point 2, 3 is equal to, and I'm literally just plugging in, so y squared, so 3 squared over, and then x minus 1, so my x is 2, so 2 minus 1. Wait a minute. So 9 over 1, so my slope is 9. So from there, let's see, 3 squared. I don't see any issues. My slope is 9. I'm going to go y minus 3 equals slope x minus 2. And then y equals 9 parentheses x minus 2 plus 3. This is the equation I'm going to use to approximate. Hello, miss. So I'm going to go f of 2.1. I'm creating the video right now. We're going to watch it, right? Okay. Give it a thumbs up so I know it's real. 9 parentheses 2.1 minus 2, close it, plus 3. I guess you could leave it like that, guys, and that technically would be full credit. But I think we're good enough that we can figure this out. 9 times 2.1 minus 0.2, or minus 2, sorry, is 0.1 plus 3. 9 times 0.1 is 0.9, so this is 3.9. And there it is. Let's see, what do we got here? Find the particular solution to the given differential equation. So we're going to start with the differential equation. dy dx equals y squared over x minus 1. I believe that's what it was. Yep. And then separate it. So x is with the x's, y with the y. So move the y squared to the left. So dy over y squared equals 1 over x minus 1 dx. And then integrate. So this guy's going to be negative 1 over y equals ln absolute value of x minus 1 plus c. And then this is probably a good place to figure out this one. So I'm going to come back and I'm going to go negative 1/3 equals ln absolute value 2 minus 1 plus c. This turns into ln of 1, which is just 0. So c is negative 1/3. I'm going to come back to this one right here. And I'm going to go negative 1 over y equals ln. And because x is greater than 1, see, x is 2. We can just drop the parentheses because it's going to be positive anyways. X minus 1 minus 1/3. And move the negative to the other side. Get rid of this negative here. So 1 over y equals, and then this, you're going to have a negative in the front of that ln, and that 1/3 is going to turn to a plus. So I'm going to write the 1/3 first, minus ln of x minus 1. And then just flip it. So this is y equals. So just move this, this 1 over y. There's an equal sign in the middle. So just go y equals, and this is like all this is over 1. So 1 over 1/3 minus ln of x minus 1. And I believe that's it. We're done. Let's make sure that if I plug in a 2, I get a 3. And let's see, ln 2 minus 1 is 1, ln of 1 is 0. 1 divided by 1/3 is in fact 3. So there it is, guys. There's better ways to do it. Maybe you put a 3 over 3 and go that route. But there it is. All right, one more. This one. So a lot of you gave up with the potato problem. It's not that bad. It really isn't. So let's read it and see what's up. At time t greater than 0, a bowl of potato is taken from a pot on a stove left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. And the internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h to satisfy the differential equation dh dt equals negative 1/4 h minus 27, where h of t is measured in degrees Celsius and h of 0 is 91. Okay, so far so good. Nothing crazy. Let's see. What do they want? What do they want in the very first? They say write an equation for the line tan to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at t equals 3. So what they're asking for is just to do a tangent line. Tangent line at the time t equals 0. So at 0, the temperature is 91. So my point is 0, 91. This is t equals 0, and this is your temperature, temp. So that's your y value there. So here we go, guys. You guys ready? I'm going to go, I need a point and a slope. This is my point. Now I need a slope. So dh over dt, this guy right here, equals negative 1/4 parenthesis. My temperature is 91. So 91 minus 27. And let's see what this is. 91 minus 27. So 91, 81, 71, 61. Plug in plus 3, 64. So I have negative 1/4, 64. And 4 goes into 64 16 times, so negative 16. 4 times 4, 16, 16 times 4, 64. Yeah, there we go. So there it is, negative 16. That's my slope. So my tangent line is y minus 91 equals negative 16, parenthesis, x minus 0. There's my tangent line, guys. And I know this is really h. That's really your temperature, and that's really a t. And I guess I don't have to put them in quotes, but there it is. So that's what I'm going to use. So I'm going to go h of 3. I'll just move that 91 to the other side. Is approximately negative 16, parenthesis, 3 minus 0, which is just 3, plus 91. And I could leave it like that, guys, but we can do this. It's not too extreme. 16 times 3, 16, 32, 48. So negative 48 plus 91. Let's see, 48, 91, 48, 58, 68, 78, 88, 88, 89, 90, 91, 43 degree difference. 43 degrees Celsius. And there it is, guys. Let me know if that was pretty tough. But there it is. That's the HDT evaluated at 0, 91. All right. We're good. Let's go to the next one. All right, let's go to letter B. It says use d squared h over dt squared to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at t equals 3. This stands for second derivative. So here we go. We already have what dHdt is, guys. dHdt is equal to negative 1/4 h minus 27. You don't have to distribute this. You can just take the derivative immediately. But if it helps you, go ahead. It's not a big deal. Plus 27 over 4. Negative times a negative is a positive. So here we go. D squared h over dt squared. That doesn't mean second derivative. Take the derivative of that. Negative 1/4 dHdt. Chain rule. Plus 0. And then dHdt I already know was this. So negative 1/4 times negative 1/4 h minus 27. And the negative times the negative is a positive. So 1/16 h minus 27. So there it is. I know because the internal temperature is always greater than 27 degrees. It says this guy right here. So since the temperature is always greater than 27, h of t is always greater than 27 degrees. So I know that this expression, this right here, h minus 27, will always be positive, and that times a positive 1/16, so this expression will always be a positive number. Now think about what that means, guys. So that means, so the second derivative is positive. That means that h of t is concave up. Concave, I can't spell today. So think about it. If you're concave up, no matter how you draw the tangent line is always below the curve, except for that point of tangency, of course, right? But if your tangent line is below the curve, then you're going to have an under approximate. So I'm going to write since is positive, comma, tangent line is below curve at t equals 3, because they did ask at t equals 3, but it's always gonna, the tangent line is always going to be below the curve at all t values. Since the second derivative is positive, tangent line is below curve at t equals 3. Hence, your approximation is going to be an under approximation because you're using, it's below the actual curve, right? Hence, approximation is an under approximate. There it is. Full credit, guys. All right, let's go to the next one. Letter C. For t less than 10, an alternate model for the internal temperature of the potato time at time t minutes is a function. Temperature of the potato at time t minutes is a function g that satisfies the differential equation. So here's my differential equation, where gt is measured in degrees Celsius and g of 0 is 91. So I still have the 0.91 initial point. Find an expression gt based on this model. What is the internal temperature of the potato at t equals 3? Okay, so separate your variables, the g's with the g's. So you're going to have dg over, and then just move. I'm not going to put the negative there. I'm just going to leave it like that. So I'm going to write parentheses g minus 27, close it to the 2/3, equals negative dt. Integrate. I guess you can put the negative in the front of that if you wanted to. So this is like, side note, like 1 over x to the 2/3. So if you bring that up, x to the negative 2/3, and we're just going to take an antiderivative. So you're adding 1. So x to the 1/3 divided by 1/3, which is the same thing as multiplying by 3. So this is just a side note. So you're going to do the same thing with this. So you're going to have 3 parentheses g minus 27 to the 1/3 equals, and then the antiderivative of this is going to be negative t plus c. And then I'm going to plug in 0.91, where 0 is the time and 91 is the temperature. So 3 parentheses 91 minus 27 to the 1/3 equals c, 0 plus c, right? So 91 minus 27, we already know that's 64. 3 times 64 to the 1/3 equals c. The cube root of 64 is 4. So 3 times 4, and so c equals 12. All right, so we're going to come back to right there. So 3 parentheses g minus 27 to the 1/3. Hello, miss. I'm almost done here. I just got one more question. equals t, negative t, don't forget that, plus 12. I need to divide everything by 3. So divide everything by 3, divide by 3, divide by 3. G minus 27 to the 1/3 equals negative t over 3 plus 4. And then to get rid of that 1/3, if you want to put cube root, you can, but raise it to the power 3. And there it is. So I'm going to have g minus 27 equals negative t over 3 plus 4 to the power 3. And then just move to 27. And there's your equation. You could, if you wanted to, expand it, but I wouldn't, unless you're like a Pascal expert or Pascal freak. Can I say that word, freak? I mean, I don't know. You do you, I guess. And then they wanted you to find the temperature at 3, so just plug in a 3. So G of 3 equals, parenthesis, negative 3 divided by 3 is negative 1. Negative 1 plus 4 is 3, and 3 cubed is 27. So 27 plus 27 is 54. Now, I make mistakes all the time, guys, so make sure to look at it. But I think that's what I got on my rubric as well. So there it is, and hopefully you watched this video and you took advantage of the extra 5 points. Just upload your document and we'll put 5 points on there, guys. All right, later, bye.